Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. So let's go and talk about types of addresses. There's a few different types of special addresses used within IPv4. Typically, the first one that has to be discussed are things called private IP addresses. These are addresses that are not allowed on the internet. They are different than a public address. Public addresses are globally routed on the internet or between ISPs. Private addresses are ranges of addresses that are kept so that they cannot be used on the internet. What ends up happening is, at like a small home, you will have a private address. For your home to get on the internet, there has to be something that will mask your private address to an ISP's public address. Your ISP provides one public address for your internet provider, or for your internet, whether it be a cable modem, a DSL, or whatever. What ends up happening is you may have 20 or 30 devices. You don't get 30 public IPs, you get one, and everything uses that single address. At home, your private addresses will either be one of three ranges of addresses. It will either be in the 10 network. Anything starting with 10 is a private IP address. For the second range of private addresses are going to be 172.16. This is going to be anything that starts with 172.16 through 172.31. Again, those are going to be the first and second octet. Those are all private addresses. Lastly, anything that starts with 192.168 are also private addresses. Again, these are not routed on the internet, so I can have a 192.168 address and you can have a 192.168 address, and it's fine. These are not allowed on the internet. Again, they're the masking that takes place that will mask these private addresses to an address that's allowed on the internet. So the masking technique is known as NAT. Network Address Translation. This is what translates an IPv4 address to a public IPv4 address. Alright, moving on, we have a special type of IPv4 address known as a loopback address. This is basically a way to test the TCP/IP stack or operations of your device. It basically says ping yourself or loop back to yourself to verify functionality. We also have a link local address. If there is no way to obtain an IP address, manual configuration did not take place, and there's no DHCP server that's able to be contacted, what do we do? Well, a link local address will be automatically assigned. They're also known as a PIPA address, an automatic private IP addressing address. This is also sometimes referred to as a self-assigned address that is automatically given to you after a given time of no address. So there used to be these things called classful addresses. Class A, Class B, Class C, and other. These had a fixed subnet length or a fixed prefix. So Class A was between 0 and 127 in the first octet. You'll notice that the private 10 address falls in Class A. Class B was anything between 128 and 191. Again, in the first octet, this was a Class B. You'll notice that 172.16 fell in this class. Class C happens to be anything that starts with 192 and goes through 223 in the first octet. This is class C. You'll notice the third private address range is 192.168. So each of these classes have a private address range. We don't do classful addressing anymore. We do classless, meaning we are not tied to the fixed length that are in these classes. A common question I get is who assigns IP addresses? There are different groups. IANA is for America. We have LACLink for Latin America. We have AFRINIC for Africa. We have APNIC for the Asian Pacific, and we have RIPE for Europe and most of Middle East and Upper Russia. These organizations control our addressing. The groups are called Regional Internet Registries. They are all managed by IANA, and that is the Internet Assigning Number Authority. This is the group that assigns which of these countries or which of these group of countries get what addresses. So let's go ahead and move on to our next section, which is all about network segmentation. We have what's called a broadcast domain. A broadcast domain is a layer 2 domain that can be forwarded. So essentially, if we have one switch and they send a broadcast, it goes to all switches. It will go out every interface except the port they received it on. It will not cross a layer 3 boundary. Things like ARP and DHCP use broadcasts to propagate information. Well, the propagate requests for information. Again, broadcasts do not cross a layer 3 boundary. So what we can do is we can have a large network. Well, the problem is the larger the network, the more broadcasts. The more broadcasts, the more resources that are used. The more resources, the slower the network operates. So what we can do is we can actually separate the networks. Instead of having one large network, we may have two smaller networks. And again, they do not cross a layer 3 boundary. So the above photo of 400 users on one network, and you'll notice the diagram underneath it, which is 2 networks, each with 200 users. The 200 users will not affect one another because broadcasts do not cross that layer 3 boundary. This is a way to segment the network. This is physical segmentation. So you'll see that each network is a physical segmentation. But in reality, we don't do this physically. Again, the purpose is so that we can reduce the overall network traffic, we can improve performance, we can improve security, we can actually look at traffic behavior, things of that nature. We can group things like by location or group or functionality or by device types. We may have all printers on one network, all servers on another network, all phones on a third network, all computers on a fourth network. The problem is this is not done through physical segmentation. In the next class, the next course, not in this course, we will talk about virtual segmentation, virtual LANs, called a VLAN. That is where we actually dive deeper into this segmentation conversation, because realistically we will not have dedicated physical segmentation. It becomes very cumbersome. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.